What is the free energy of mixing 1 mole of polystyrene, molecular weight 2 times 10 to the 5 grams per mole, with 1 times 10 to the power 4 liters of toluene at 298 Kelvin? So free energy of mixing delta G is given by delta Gm is kT times N1 ln V1 plus N2 ln V2 plus chi N1 V2, where K is a Boltzmann constant, T is the temperature, N1 and V1 are the number of molecules, and volume fraction of the solvent. N2 and V2 are the number of molecules, and volume fraction of the polymer. Chi is the Florey-Huggins parameter for the given solvent polymer. So let's find kT. K is 1.38 times 10 to the negative 23 joules per mole, and temperature is given as 298 Kelvin. So kT equals 411.24 times 10 to the negative 23 joules. So we have 10 to the power 4 liters of toluene, which is 10 to the power 7 milliliters, or 10 to the 7 cubic centimeters of toluene. Molar mass of toluene is 7 carbons, so 7 times 12 is 84. 8 hydrogens, so 8 times 1 is 8, so it's 92 grams per mole. Density of toluene from table 3.2 is 0.8669 grams per centimeter cube. So mass of toluene is density times the volume, so it's 0.8669 grams per centimeter cube times 10 to the power 7 centimeter cube, which is 10 to the power 7 times 0.8669 grams. Number of molecules of toluene would be the mass divided by the molar mass, which is 92 grams per mole, times 6.023 times 10 to the 23 per mole, which is the Avogadro number. So the number of molecules comes to 567.5 times 10 cube times 10 to the 23 molecules. So this is N1. Total volume of toluene and polystyrene is volume of toluene plus volume of polystyrene. Molecular weight of polystyrene is given as 2 times 10 to the power 5 grams per mole. Density of polystyrene from table 3.2 is 1.06 grams per centimeter cube. So number of moles of polystyrene is given as 1 mole. So mass of polystyrene is 2 times 10 to the power 5 grams per mole times 1 mole, which is 2 times 10 to the power 5 grams. So volume of polystyrene is mass over density, which is 2 times 10 to the power 5 grams over 1.06 grams per centimeter cube, which is 188,679 centimeter cube. So the total volume is 10 to the power 7 centimeter cube of toluene plus 188,679 centimeter cube of polystyrene, which is 10 to the power 7 times 1 plus 0.019 centimeter cube, which is 1.019 times 10 to the power 7 centimeter cube. So this is a total volume V1, that is volume of toluene, which is 10 to the power 7 liters over the total volume, which is 0.98. So V1 equals 0.98. So V2 is the volume of polystyrene, which is 188,679 milliliters over the total volume, which is 10 power 7 milliliters, and that is 0.019. So V2 is 0.019. N1 is 567.5 times 10 cube times 10 to the 23 molecules times ln V1 is ln 0.98, and that is negative 11455 times 10 to the 23. N2 ln V2 would be number of molecules of polystyrene is 6.023 times 10 to the 23, since it's just 1 mole, times ln V2 is ln 0.019, which is negative 23.87 times 10 to the 23. Chi N1 V2 is, value of chi from the table is 0.37. So 0.37 times N1, which is 567.5 times 10 cubed times 10 to the 23, times V2, which is 0.019, and that is 3990 times 10 to the 23. Now, delta G of mixing is Kt times N1 ln V1 plus N2 ln V2 plus chi N1 V2. So Kt was 411.24 times 10 to the negative 23. N1 ln V1 is negative 11455 times 10 to the 23. N2 ln V2 is negative 23.87 times 10 to the 23. And chi N1 V2 is 3990 times 10 to the 23. 411.24 times that gives us 3080 kilojoules.